Hello, Math 2 students. It has been a while. I'm here to teach you section 5.6 on the day before Thanksgiving break. Super exciting, we're almost there. So section 5.6 is on proving parallel lines, and we're going to start by looking at the converse of each of these statements that you learned about in section 5.5 yesterday. So corresponding angles postulate. The abbreviation we use for that is either CA or CAP. And then the next one is if we have alternate interior angles, that's AIA. And then we have CIA, consecutive interior angles, and AEA, alternate exterior angles. And so the converse of each of these statements is that rather than saying if we have two lines that are parallel, then we have corresponding angles that are congruent, we're now going to be saying if we know that two angles are congruent in their corresponding locations, then that means that the lines will be parallel as well. So it's just the opposite that we're saying. If we have alternate interior angles that are congruent, then the lines must be parallel. Remember, for consecutive interior angles, that's if they're supplementary, so if they add to 180, then the two lines are parallel. And then the last one is if you have alternate exterior angles that are congruent, then the lines will be parallel. So in 5.5 yesterday, we would say if we know two parallel lines, then we know that these two angles are congruent. Well, now we're saying if we know that these two angles are congruent, then we can say these lines are parallel, even if we didn't know that beforehand. So, looking at these first two problems, it says find x so that the two lines DE and GH are parallel. So we want to prove that these two lines here are parallel. And if we look at the two angles where we were given some information, these two angles are alternate exterior angles, meaning they are on opposite sides of the transversal, so alternate sides of the transversal, and exterior, so outside of the parallel lines. So if we have alternate exterior angles that are equal, looking back at this one, then that means that we know the lines are parallel. So what we want to do here is set those two angles equal. And if we set the two angles equal, then we can say that the two lines are parallel. And then we're just solving for x from here. Add 72. So 4x equals 112, divide by 4, x equals 28. So again, what we're saying here is if we know that this angle here, so this was angle BAE, angle BA, is equal to angle, and this one here is CFG. Again, if we set them equal, that means that our alternate exterior angles are congruent, and therefore the lines would be parallel. And number 2, it says find x and angle RSU so that M and N are parallel. So we're trying to prove that these two, or we want to make it so that these two lines are parallel. So for angle RSU, we're given 8x plus 4. And for angle STV, we are given 9x minus 11. And so these are corresponding angles. And if we set these two angles equal to each other, then we'll get corresponding angles that are congruent, which will tell us that the two lines are parallel. So if we set these equal, solve for x, I'm going to do both of these steps in one, so that would be 15 equals 1x. 15 is x. And so it said find x and angle RSU. So we need to plug x back in to find what the angle is. So if we plug in 15, so angle RSU equals 8 times 15 plus 4. That's going to be 120 plus 4, so 124 degrees. And you could plug it into the other angle as well. You should also get 124 since they're equal. So that's kind of the general idea here. Now we're going to be looking at what we call hashtag proofs. They're called hashtag proofs because they look something like this. And for hashtag proofs, oh, and one more thing on the previous two problems. Just because you're given two angles doesn't mean you're always going to set them equal to each other. Don't just assume you're going to set them equal, because it's also possible that you might be given like consecutive interior angles. So like these two angles here, in which case you would not set them equal. You'd add them up to 180. Same thing if you were given this angle and like this one, they would add to 180. So make sure you're careful not to just set things equal just because we did that for those two examples. So for hashtag proofs, they're going to be 4 steps every time if you do them the way that we teach them. So for hashtag proofs, you're going to start by labeling the points and the lines. And we like to label the points with numbers instead of using the angles with numbers instead of letters. Makes it a little bit easier when we're doing the proofs. And then the second step is going to be to identify the parallel lines, meaning which lines we are given are parallel. So when you see that there's 2 sets of lines that look parallel, more than likely only one set you know is already parallel. And then our third step is going to be to draw a line or draw an arrow across the transversal. Make sure to keep track of which lines are parallel, which ones are the transversals. And then we use the transitive property. So it's going to be 4 steps, and in general the proofs will be 4 steps. We'll look at that when we get to numbers 3 and 4. Those are what you're going to be expected to do on the test. So, looking at these first 2 examples, we are given that angle XYW, that's this angle here, plus UXY, this angle here, add up to 180. So I'm just going to number these. I'm going to call them angles 1 and 2. So I'm saying this is angle 1, this is angle 2. And it says to write a 2-column proof, and for these first 2 problems, they're only 2 steps. They're really straightforward. So start with our statement. Our statement is that angle 1 plus angle 2 is equal to 180, and we know that because it's given. We're trying to prove that these 2 lines, TU and VW, are parallel. You cannot go ahead and you can't go label them beforehand and say they're parallel because we weren't given that information. That's what we're trying to prove. So because we know these 2 angles add up to 180, therefore we can say that the lines are parallel. TU is parallel to VW, and that's because of these 2 angles adding to 180, meaning that they are consecutive interior angles. And if you think back to what we went over up here, we said consecutive interior angles. If the consecutive interior angles are supplementary, then the lines are parallel. This is known as the converse of the statement. So I'm going to be writing converse for these. You don't technically have to, but it might make it a little bit easier to keep track of what you're actually doing. So you can see, okay, because I know these 2 add up to 180, therefore since I have those angles, I can go backwards and say that the lines are parallel. And then for number 2, we have angle MPQ, that's this angle here, is equal to NQP. So these 2 angles, they are both inside the parallel lines on opposite sides of the transversal, or what we think might be the parallel lines. So that would mean that we're going to look to see these are probably going to be alternate interior angles. So I'm going to start by numbering these angles, angle 1 and angle 2. You don't have to number the angles, you could just write in your proof angle MPQ equals angle NQP. But in general, when you get into the harder proofs, it is a little bit easier to follow if you number them. So our statement is angle 1 equals angle 2. This is given. Because we know those two angles are equal, therefore we can say that lines LM and NO are parallel, and that's because alternate interior angles are equal, so that's the converse of alternate interior angles. So that's kind of the our goal for these next proofs, is to come up with a statement like one of these that we can use to then say, because of the converse, we know the lines are parallel. And again, these proofs are going to be 4 steps. They should be 4 steps each time, unless you do something else, which you can do it in more steps and still have it be correct, but if you're following the format that we like to teach it in, then it should only be 4 steps. So we're going to start by following the steps that were given above. It says label the points and lines. So I'm going to go ahead and number these, and I recommend that you just use the same numbering so you can keep track of it, because it can get kind of messy. So if we number these 1, 2, 3, 4, and in general they'll be numbered for you: 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it says label the points and the lines. So we're given that DE is parallel to GH. So these two lines are parallel. So it says to prove, we're going to try to prove that BC is parallel to JI. However, we are not given that. So at this point, we're assuming these lines could be slightly off, right? This one could be going here, this one could be going slightly at an angle where they're not quite parallel. So that's what we're assuming, because again, we were only given 2 lines that are parallel to each other. And then we have angle KAF. So KAF would be here, that's angle 4. So angle 4, I'm going to circle that so we know we're working with that angle. And angle FLK. FLK would be 13. So we just labeled the parallel lines. I don't know where my labeling went to. They're right here. Which means if those are the 2 parallel lines, then at this point, BC is a transversal, and this is also a transversal. You don't have to label that, but I recommend you do that for when we start working through the proof. It can seem really straightforward, and then it gets a little complicated because you have to make sure you're going the right direction. So our statement is that DE is parallel to GH, and angle 4 is equal to angle 13. That was given. So we're 1/4 of the way through the proof. And this is where you've got to make sure that you're going the correct direction. So in the steps above, it said identify the parallel lines and then draw an arrow across the transversal. One way that I like to do this is, rather than, so you can draw an arrow, you can say, all right, I know that the transversal is going this way, so I'm either going to use this transversal or this one. Again, pick a transversal and use that one. Or the way that I like to do it is to cover up the transversal I'm not using. So because we know that these 2 lines are parallel here, we can only use one of the 2 transversals, because these 2 transversals are not parallel to each other necessarily. So I pick a transversal and then cover up the other one. So when I say cover it up, I don't recommend you actually cross it off, because it could get kind of messy and you want to be able to see what was under there. But you can put a pencil over it, or put your finger over it, or cover it with another piece of paper. So again, you cover a transversal, whichever one you're not using. And then we're going to look and say, all right, with angle 4, since that's the one that we're working off of, what is angle 4 equal to? So I can say, because the 2 lines are parallel, I could say angle 4 is equal to, let's just go angle 12. So we know angle 4 is equal to angle 12 because those lines are parallel, which means that they are corresponding angles. Then your third step is always going to be the same. The third step should always be using the transitive property. And you use what you've already got in your proof. So if you look at the proof, we have angle 4 equals angle 13, and we also know angle 4 is equal to angle 12. So because angle 4 equals 13 and angle 4 also equals angle 12, we can say angle 13 is equal to angle 12. So again, we're not basing that off of here. We're not saying, oh, these are equal because we have two parallel lines. No, that would mean that we just use those transversals. That is not how we found that 13 and 12 are congruent. We used these two parallel lines, and then we used the transitive property. So now that we've done that, we can go ahead and do our last step, which is say, so the fourth step is going to be saying that these two lines are parallel. So BC is parallel to JI. And that's because, so now we can look at this, we can say we know that 13 and 12 are equal. We know that because of what we've already done. And because they're equal, that means that our alternate interior angles are congruent. And we said up here, if you have alternate interior angles that are congruent, then your two lines are parallel. So I recommend you put converse here so you can keep track of it. So in step 2, we used corresponding angles. So we said because we knew these two lines are parallel, we could set the angles equal. We knew that they're equal to each other. And then in the fourth step, we're saying because we know that our alternate interior angles are equal, therefore we can say the two lines are parallel. There's 3 other ways that you can do this proof in only 4 steps. And I'm just going to kind of do an overview of that real quick. And then I want you to also know that there's 4 ways that you could do this incorrectly, or more. Well, there's tons of ways you could do it incorrectly. But mostly what I mean by that is, so if you had used the same transversal, we could have said 4 was equal to 9. So you could say here 4 was equal to 9 because they're alternate interior angles. In which case, when we use the transitive property, we would have done 4 is equal to 13, 4 is equal to 9, so you'd set 13 equal to 9. Again, transitive property. And then your last step would be still saying that the lines are parallel, but then in that case, looking at 9 and 13, we would then say that's because of corresponding angles postulate, converse. So you can see in that case, these are just swapped. The other way you could do it would be to use the other transversal. So if we had covered up, and this is what I mean, it starts to get kind of messy. If we use the other transversal and we covered up the one on the left, so here, then we would be going this direction. So we could say 13 equals 5, or you could do 13 equals 8, and then you'd use the transitive property, and then we go the other direction. So again, either of those 2 ways you can do it. Just make sure that you do not go this direction to start, because if you go this direction, that means that you're using these 2 transversals as parallel lines, and they are not parallel. So try to be consistent to make sure that you do it correctly. So I'm just going to go back to the proof I had done originally. 4 equals 12, and then we went off of that. So let's look at number 4. Again, there's numerous ways you can do it, but make sure that you understand the way that I'm showing it so you can be sure that you did it one of the correct ways. So our statement is that R is parallel to S and angle 5 is equal to angle 6. That was our given information. Wow, these lines are not parallel, that's for sure. Draw my transversal through the 2-column proof, which is also not. There we go. Okay, so we know angle 5 is equal to angle 6. And then these 2 little pink triangles are telling us that they are parallel lines. It also said that in the given. R and S are parallel. So if R and S are parallel and we're trying to prove that L and M are parallel, we're not given that L and M are parallel. We're trying to prove that, which means that these are just transversals at this point. So these are both transversals. So when it comes to drawing an arrow across a transversal or covering a transversal, so it's out of sight, so you don't try to use it. So we're going to cover a transversal, and then we're going to determine what either angle 5 or angle 6 is equal to, and then we'll go from there. So again, it doesn't matter which transversal you cover as long as you cover one of those. So I'm just going to cover this one. And if I cover that one, that means that I want to go this direction. So I know at this point, if we just use the angles that are given there, angles 4 and 5, I can say angle 4 plus angle 5 is equal to 180. Those are consecutive interior angles. They're supplementary. And then from there, we can say, looking at the transitive property, or in this case, it's technically substitution. If you said transitive, though, it would be fine. So angle 5 is equal to angle 6. So we're going to substitute in angle 6 for angle 5. So I just replaced angle 5 with angle 6. That was just substitution. Or again, transitive is fine too. So now that we've shown that angle 4 plus angle 6 is equal to 180, if we get rid of having crossed that off, now we can see 4 plus 6 is equal to 180. Therefore, if they add up to 180, that means that my consecutive interior angles are supplementary, and therefore I can use the converse to say that L and M must be parallel. So again, we did not start with that. We proved that. You also could have used, so you could say like angle 5 is equal to, and then you could number this one something else. So you could say angle 5 equals angle 3 instead. That would be alternate interior angles. And then you could say angle 3 plus angle 4 equals 180, and then you could substitute that in. It would just be a lot more steps. So it's generally easier to go off of what you're given, so that way you don't have to turn it into something more. The other way we could have done this would have been to cover up the other transversal instead. So I could have covered up this one, in which case we'd say angle 6 plus angle 7 equals 180. And then we'd go from substituting, we'd instead substitute angle 5 plus angle 7 equals 180. And then we could say the lines are parallel. Same reason again. Either of those two ways is correct. Just make sure that you don't go this direction. If we went this way and said 4 equals 6, that would be incorrect because that would be assuming that L and M are parallel. We don't know that they're parallel. We just know that they are transversals. So hopefully that made sense. Again, overall for your steps of the proof, start with the given. You should only be doing 4 steps in total. Your third step should always be substitution transitive, assuming you did it in this format. Your last step should always be proving whatever it was that's parallel, those two lines. So you really only have a few things to fill in, and I'd say the hardest part of this type of proof is just determining what the second step would be and making sure you do that correctly. So hopefully that makes sense. Feel free to reach out to your teacher if you have any questions.